Yeah, motherboards. Look at this. All these AM4 motherboards. Some old ones like the AB350 Gaming ITX AC. Some new ones like Thunderbolt on AM4. The MSI Ace and the Creator and Asus. Everybody's represented here, even BioStar. But I am behind on my videos on AM4. And the reason for that is this launch has been rough. But, well, it's not as launch as the X99 rough launch. Because, yeah, I mean, I'm still waiting on USB drivers to be fixed from the X99 launch. Maybe not as bad as the X299 launch, because Intel took away support for registered error-correcting DIMMs on X299. Yeah, people don't realize, but 7000 series CPUs, like the 7980XE, you could totally use a half a terabyte of memory, 512 gigs. Intel took that away, they snatched it away. Giveth and taketh away. But this from AMD, all of this, it's a revolutionary product. The roughness really is just disorganization, I think, and some disorganization around the underlying technology. Now, I have spent hundreds of hours investigating boosts and performance and clocks and thermals and just doing all sorts of testing and general insanity. And it is very hard to quantify. There are so many variables, and really small changes have very subtle effects. Now, I'm sure that some folks inside of AMD have been working continuously around the clock for the last several weeks, solving problems and doing stuff. But solving problems at scale is hard. I mean, at this point, AMD's produced hundreds of thousands of CPUs, if not millions of CPUs, and they're coming up with one piece of software to rule them all. It's harder than forging the One Ring and Mount Doom. So things have been squirrely from motherboard vendors as well. I mean, some motherboard vendors seem like they're coming out with UEFI updates, BIOS updates almost daily, and some of them are waiting weeks and even almost a month in between updates. The AIB partners all did different stuff too. I mean, there's a lot of variation, which is good. We've got Thunderbolt on AM4 from ASRock. We've mostly got Thunderbolt on AM4 from Gigabyte. There's an upgrade header, snafu around that maybe. The implementations are different. Asus was like, hey, we figured out the memory controller thing, and we're gonna have really awesome memory support out of the box, although I don't really know if that's materialized, but we'll talk more about that in a minute. And Gigabyte's got the formula down pat. I've got a Gigabyte board in my Dr. Zaber mini PC thing, and I'm actually running the 3700X at the 65 watt TDP. It's not overheating and it's working correctly. So motherboard vendors do seem to be a bit frustrated though. Basically, across the board, universally, if I were to make generalizations, I would say that motherboard vendors are basically frustrated. And I think that's because they might be used to things like Intel's reference design. AMD's not going to be so presumptuous as to say, hey, implement this. They're sort of, it's like, you do electronics, you do motherboards, you do you, let's put it together. I've done testing with Windows and Linux across 6-7 different CPUs, a whole bunch of different Agiza versions and BIOS versions and all that kind of stuff. We are going to have a look at all that data from Geekbench and Cinebench and some other stuff like that. There's actually a user on Reddit that compiled all of the Geekbench submissions, and Steve from Hardware Unboxed did a video. So, the Reddit data. Well, the Reddit data, it's really from Geekbench, but somebody on Reddit put it together. And, Robert Halleck said 4.5 gigahertz is the max boost in that video that everybody has seen, and you might be able to get 4.75. And so everybody's saying, oh, there's not a CPU that does that. I'm going to drop a bomb here. The 3800X advertises a 4.5 gigahertz maximum boost to the system. How do I know? Well, there are some low-level variables in the system called DMI variables, and in these, the CPU will actually tell you what its maxed boost speed is. So DMI decode the variables, and lo and behold, the 3800X advertises a max speed of 4550. Same with the 3900X. Max speed is 4650. So 4550 and 4650. Now the 3700X, that's a different story. It advertises a max boost speed of 4400. No extra 50 megahertz. That's going to be really important here in a sec. Now, I think just like the Ryzen 2700X, AMD advertised on the box a slightly lower boost clock speed, knowing that the very top boost clocks would be a little bit fleeting. So again, I think it was AMD's intention to underpromise and overdeliver. But something has gone wrong. And so you might be thinking, what's the post-mortem then? Why, have you taken so long to put together motherboard videos? Why is the performance still so varied across a whole bunch of different boards? Well, in Steve's video, it's pretty clear. There's a 1 to 3% variance across boards in real-world performance, but the clocks themselves can vary more than you would think that they would. And for me, it was the thermals that varied more than the performance. So you've got that Dr. Zaber mini PC, and I've been trying to get the 3700X to work at its advertised speed reasonably well without just completely hitting TJ Maxx 95C all the time. So you would think that, hey, that 1.0.0.2 Agiza version with the older SMU with the higher boost clocks would actually perform better. But these versions are for the Tai Chi, the Godlike, the Asus Crosshair Hero 8, and the Aorus Master. 1.0.0.2 with the older SMU was what was provided at launch. And so if you have the chipset driver as well, the cooperative multitasking thing that could use the favored core, then together those things you would see, the 4.6 gigahertz boost or whatever. Now remember the Ryzen 2000 CPUs. The Windows Scheduler thing didn't exist for the Ryzen 2000 CPUs, you didn't need a chipset driver or anything. The chipset driver came out with Ryzen 3000, and so a 2700X could boost to its advertised boost on all the cores. So in the case of the 2700X, that means the maximum boost was basically available everywhere. Well, with the 3900X, we know, because there's multiple chiplets, it's very clear from our data and the users' data that's been submitted through the Level 1 forums that there's one good chiplet and one kind of meh chiplet. The meh chiplet is binned for around 4.3 gigahertz speed based on the data. It's an educated guess, I don't know that for sure, no confirmation from inside AMD, just a guess. And that makes sense, because you got the good chiplet, and with the cooperative driver thingy, it's gonna load up the good chiplet first, and then it's gonna load up the meh chiplet. And that's what AMD has told us is supposed to happen with the new cooperative driver. This lower bin chiplet would be somewhere between a 4.2 gigahertz Ryzen 5 3600 and a 4.4 gigahertz max boost Ryzen 5 3600X. And AMD has shown that they are exceptionally good at binning their chiplets, at binning their silicon in general. Now, in our video that we did a while back on the 3800X, we showed that it had higher overclocks from manual overclocks and core boosts versus the 3900X and the 3700X. So that's better silicon quality. And that is backed up by the Geekbench data that we're looking at, from the Reddit post. It's just better silicon on the 3800X. Now, note, we're not talking about PBO. PBO is still broken. I don't think that PBO is working correctly yet. Getting closer, maybe. We'll talk more about that in a minute. Silicon Lottery. Silicon Lottery has also released their data and binning stats, which included the 3800X. And if you add that to what we're talking about now, the 3800X, 4.3 gigahertz, 1.3 volts, that's a top 20%, 4.2 gigahertz all core. So the top 20% of CPUs will do that. While the top 21% of the Ryzen 7 3600X could only achieve 4.15 gigahertz all core. That's a 150 megahertz difference in all core speed. So you might be thinking, well, clearly the 1.0.0.2 Agiza is going to be better performance with the observed higher clocks, right? No, not at all. In fact, it's kind of weird. The performance varies. We've got Geekbench multi-core and single-core from Linux and Windows on both versions of the Agiza. And across many runs, there's a lot of variation, but it's within margin of error. The thing that makes a bigger difference, especially on Linux, is the performance governor. Between performance, which doesn't perform as well as on demand, and that may be down to thermal considerations. Again, we're using the reference stock cooler on this for this testing. So back to the data from Geekbench on Reddit. The 3800X is really boosting the way that I would expect in this data pretty much. There's one thing that you might not take into account if you just look at the raw data, but it is consistent with my experience. And so you should realize that the yellow line on the graph that they made from the Reddit data, or from the Geekbench data on Reddit, is just AIB partners slightly underclocking F-clock. You see 99.8 megahertz instead of 100 megahertz. That might be something called spread spectrum, which is another conversation. Or it might be an AIB partner underclocking for stability. The 3800X does look like it is boosting, and boosting reliably, at least half of them. And I found the best stability, personally, on the Gigabyte boards, both on the ITX and the Aorus Master, at 100.01 for whatever reason. About half of the 3700X results are also what I would expect, because remember, the front side bus clock, underclock, so 99.8, and you do not get that extra 50 megahertz bump. They advertise 4.4 on the box, you get 4.4 with the 3700X. This clearly shows the advertised boosts are not quite as fleeting as some of the complainers would have you believe. But I do think something has gone wrong with the 3900X, and it seems weird that the 3700X doesn't advertise the extra 50 megahertz bonus the way that the 3800X and the 3900X do. So after endless fiddling, my two 3900Xs that are in the tiny green segment on Geekbench, they're performing correctly, but these are in the minority, and it took a lot of fiddling. So that's kind of annoying. And I could see why a lot of people with a 3900X might be upset. And I can see why some people might be worried about other things. But hopefully, we're sort of rehabilitating the picture, because between the actual realized performance and, hey, the clocks are kind of sort of where they're supposed to be, at least in Geekbench and aggregate, it's looking better. Now, I've gone through 2 tubes of Arctic MX2, so thanks Arctic. And we've gone through Cinebench and Geekbench and CPU-Z, and generally, the newer Agiza is better for single core and multi-core. But I've observed some really weird behaviors with Cinebench. So for example, sometimes it seems like the system would just pick a clock speed and just run with it for the entire Cinebench run, and that might be 4 gigahertz or 4.1 gigahertz or 4.2 gigahertz, and it seemed not to really be related to temperature unless you were sort of entering temperature extremes, which is very weird, and trying to chase this down has shaved 5 years off of my life probably, because it doesn't make sense, because it doesn't behave deterministically, and that's what's driving me insane. So I bet you the engineers inside AMD are also going insane from trying to figure out why this is not behaving deterministically. Now that 1.0.0.2 Agiza also has a lot of other problems. For one, IOMMU. The IOMMU on 1.0.0.2 is a dumpster fire. It is broken. It does not work. So I think 1.0.0.3 introduced a lot more complexity and overhead, and the fact that this thing runs 1,000 times a second, monitoring the CPU and making adjustments for temperature and all this other kind of stuff, I think that it just can't respond quickly enough. I think the Agiza maybe has gotten too complicated to be able to run quickly enough to run and change conditions, and maybe that's why it cannot boost as high, because the Agiza is kind of doing a lot of stuff. If nothing else, it's managing, memory isolation because of things like IOMMU. So some people have been freaking out about voltages and temperatures, and again, it's the current density and the temperature to worry about if you're worried about electro-migration. So this is a little different conversation, but it's kind of tangentially related to what we're talking about. If you aren't sure what electro-migration is, basically heat and current density can degrade the processor, which might make it stop working altogether. And this is because the inertia of electrons start moving atoms around, and then eventually there's a short, or eventually a wire comes unplugged or whatever. It does accelerate with higher temperatures, and the newer 1.0.0.3 Agiza lowers the performance ceiling from 80 degrees C to 75 degrees C, 5 degrees C. Now TJ Maxx is still 95 degrees C, but that lowering means that you're not going to see boost clocks quite as high. So I had a thought, what about second gen Ryzen? I mean, this Agiza and SMU, these motherboards are designed to be interoperable, right? So let's try a second gen CPU. Well, it's a mess there. ASRock and many other partners actually plainly print on their webpage, do not upgrade unless you're running a 3000 series Ryzen CPU. It's a pain to downgrade. It is possible to downgrade. I went through a complicated procedure to downgrade on my Taichi X470. You have to boot into an EFI command shell and run some commands, and there's a chance that you might brick the board if you do it incorrectly, but that allowed me to move between those two different versions. Now, the Gigabyte Aorus Master will let you, or the Aorus Extreme will let you toggle between an A and a B BIOS. So that makes testing really easy, and I use that for testing as well, because I could try the NRP Press BIOS, which is on Gigabyte's website, as well as the 1.0.0.3 Agiza, and just swap between them with the switch. It's great. Now, I found that marginally the clocks and performance was reduced on second gen Ryzen with this new 1.0.0.3 Agiza. So the new second gen Ryzen CPUs are now targeting 75 degrees C before they start, super downclocking instead of 80 or whatever it was previously. Another thing I discovered after going through all that thermal paste, is that sometimes you can roll a 1 on the thermal paste and it doesn't behave like it just doesn't seem like it behaves right. So like taking it all apart, cleaning everything and repasting it again. I found that the most reliable approach was to put one little pea-sized dot of thermal paste over where each chiplet is. So if you look at the diagram on screen, you can kind of see what that is and put 3 dots. Even if you only got a 2 chiplet CPU, just go ahead and put 3 dots. They give me newfound respect for AMD's box cooler because it's direct touch heat pipe cooling. It actually works exceptionally well, and those 7 nanometer chiplets get insanely hot very quickly. It's a very tiny amount of area that gets super hot. So you might be thinking, hey, what tips do you have for me? I'm a motherboard owner. Well, as I review each motherboard in these giant stacks, I'm gonna post the guide to the perfect setup where I could get my 3800X or 3900X working really well. I've already done that with the Gigabyte boards. I've got the Dr. Zaber build and the Gigabyte ITX board, the 3700X, and it is really singing. I am very happy with it. I've got the Noctua cooler in there and it's working great at the 65 watt TDP. It doesn't get super hot. It works great for gaming, even very long gaming sessions. There is definitely a power and thermal budget within these chips that works a little differently. And you should also know that memory speed and PCIe 4 affect that power and thermal budget more than most people realize. Probably gonna cover this in later videos. The frontside bus clock, also a slight underclock, can make a big difference in overall performance. And there isn't really one universal thing I can tell you to do because I get better boosts and better performance actually just targeting exactly 100 megahertz versus like trying to underclock it to 99 megahertz on the frontside bus clock or F clock, or trying to target like 101. Some people have targeted like 101 or 102 to get like an even higher boost. And I've got one CPU, a 3900X, where I can hit 4.7 with like a 103 to 104 overclock. So some people are worried about like the voltage and the observer effect. There was a thing on that. Robert Halleck did a nice write-up on the voltages. That's actually good. Some people are freaking out about 1.5 volts and electro-migration, but there's a difference between current and current density. And at stock settings, this is really the least important thing to worry about at the moment, I think. I just don't see that as much of an issue. Some of the updates from AMD seem to have added a middle temperature that's between, like cold and 75C, where you get like middle clocks. But I keep going back to the press kit slide where it's showing 4.3 gigahertz all core 3900X. It's just basically a line, and the line's just a hair under 4.3, but that's what I keep going back to in my head. It does seem like it's designed to boost to that speed in all core scenarios because of my fiddling with the secondary chiplet. And after a lot of fiddling and fiddling around with the voltages and the offsets and slightly underclocking it, memory speed tweaking and secondary subtimings, yes, I can say that I am getting 4.25 to 4.3 on my 3900X all-core with 4.5 to 4.6 in lightly threaded scenarios. Others on the Level 1 forum have not reported as much success copying my settings, but more success than stock. So currently I'm using the Noctua U12S, and I'm happy with that. It runs really well, but I am running the memory at 3533 with very tight subtimings because I found that's the difference between basically a 4.5 gigahertz cap and a 4.6 gigahertz cap for lightly threaded stuff. Now, I can run 3800 with this CPU, even 3733 and 1866. But for me, that would limit how much my CPU can boost. PCIe 4 on my particular 3900Xs doesn't really seem to make much of a difference. Maybe a little bit of a difference. But disabling PCIe 4 for the chipset and for NVMe peripherals doesn't really seem to make much of a difference on those CPUs. But it has for people on our forum. So I did something else. I went a little under the radar. A lot of this stuff that I bought at retail, which means that I should have retail support. So I reached out to AMD under the radar. And I can reproduce some issues like running Cinebench R15 several times in a row on 3700X and certain boards will cause the temperature to spike up to 95C. And in some scenarios, that's not acceptable on a 3700X, but if you're trying to build a small form factor machine, that may be an impossible situation. So I reached out, not as a YouTuber with clout, just some random Joe wanting support. And so, long story short, this is where we ended up after a lot. Thank you for providing the requested details. We are aware of the behavior and I have escalated this to the team internally, and that team is looking at it. As a YouTuber with some clout, there isn't much they can share right now. In the grand scheme of things, I think the thermal problems, especially for low power systems, are perhaps more serious than the performance issues, at least based on all this testing. And I had, some of the thermal issues that I had could be attributed to things like ASUS's aggressive voltages, which are quite aggressive, and I think are being worked on or maybe fixed. Some users have been frustrated with the infrequency of updates from their motherboard vendors. And well, in this situation, I can't blame them. I mean, some code from AMD, which is an opaque binary blob to the motherboard vendors can't see it, has been really buggy. So it's like AMD hands this buggy ball of insanity to the motherboard vendors, like, okay, test this. And it's like, this is terrible, send it back. So we do have the launch of the 3950X coming up, 16 cores. Presumably, this will be with 2 top quality chiplets, unlike the 3900X, which is 1 top quality chiplet and 1 kind of chiplet. The overall fix from AMD is probably pretty easy, actually. Hire more people, more talented folks that their existing talented folks can delegate testing and integration and things like that. Because obviously AMD has some top talent people to produce this. Again, don't get me wrong, this is an amazing processor. I do believe this also looks worse than it is. My recommendation to you, if you pick up one of these, is just pop your CPU in your motherboard, do some baseline tests to make sure you haven't gotten anything really wrong, and then enjoy your CPU. Stop chasing the last 1 to 3%. It's not worth the headache. Oh, and overclocking? Overclocking is definitely not worth that headache, at least not right now. It's not like 2nd gen Threadripper, or even the 2700X, where you can enable PBO and enjoy free extra performance with no real stability loss. We are not there yet on Ryzen 3000. That does not exist right now for Ryzen 3000. That's really all you're giving up if you're thinking about buying this platform. So I definitely think that it is something that needs to be addressed, but it's not as serious as people make it out to be. It is a little bit more varied of a problem on the older X470 and especially X370 motherboards, but the situation is improving as far as I can tell. But I'm gonna withhold judgment until after I see what happens with the 3950X launch. I'm Wendell. I've got a lot of work to do to get on with the motherboard launches and the motherboard reviews, because we got Thunderbolt on AM4. I've got to test Thunderbolt peripherals on AM4. How exciting is that? I'm Wendell, this is Level 1, I'm signing out. I'll see you later. Join in the comments. Join us in the forum. Let us know what your experiences are. The data looks interesting.